Hello and welcome to another AQA GCSE 8300 series revision video. In this video we're looking at paper 1H of the May 2017 first paper in the higher tier. This is a non-calculator paper, so we're not allowed to use calculators, and we pick it up in question 21. And 21A says the diagram shows rectangles A and B. Okay, so we've got two rectangles. It says rectangle A can be mapped to rectangle B by a single transformation. Javed says the only single transformation is a reflection in the y-axis because the rectangles are on opposite sides of the y-axis. Is he correct? Well, he's correct that there is a single transformation that can map A to B, which would be a reflection in the y-axis, because this is the same distance. The nearest point to the y-axis is the same distance as the nearest point to the y-axis. So A is a reflection of B, but the key word which has been emboldened is only, the only single transformation. And if we can think of just one other single transformation that can map A onto map B, then Javed is incorrect. And I can think of a very simple one, because all we have to do is translate A to B. So it's simply a translation of 1, 2, 3, 4, 5, 6. So a translation of 6 units along the x-axis would map A onto B, because they have a symmetry here. So even the reflected image is the same as the original image, so you can just translate them. So Javed is not correct. A translation of 6 units along the x-axis will also work. Okay, 21B says the diagram shows triangles CDE and PQR. CDE is mapped to PQR by combining two single transformations. The first is a rotation of 90 degrees anticlockwise about E. Describe fully the second transformation. Okay, so see, I can think of three transformations that would be necessary to get to PQR from CDE. One is a rotation, the other is an enlargement, and the other is a translation. But according to this, we only need two single transformations, and the first of which is a rotation of 90 degrees anticlockwise about E. So let's do that. Let's figure out what a rotation of 90 degrees anticlockwise about E would be. Well, a clock starts at 12, and then it goes 1, 2, 3, and so on round this way. So this is clockwise. So anti-clockwise would be this direction. So we're taking this whole shape and we're moving it in this direction. Now it's rotating about point E, so the new origin is point E. So this point will not change. So E will be E prime, which I'm going to use to label new E. So that point doesn't change. Now what's happening to point C? So we're going up 1, 2, 3, and then we're going -1 along the x-axis. So it's -1, 3. So we're going to rotate 90 degrees. So the y-axis, then becomes the x-axis, and the x-axis becomes the y-axis. Now we're looking at, if we're going up 3, then we need to go across -3. So this is going to be 1, 2, 3 here, and we went left 1, so we're going down 1. So this is the new point C, so this is C prime. Okay, so effectively this x comma y maps to -y comma x. Now to get to point D, again we're still going up the same 3, so we're going to end up here, but we're going right 1, so this is +1. So we're going -3 along the x-axis and +1 up the y-axis from point E. So this is our point D prime, or our new D. Let me try and draw this triangle. I'm going to draw it in a different colour. So this would be our new triangle. This is the triangle CDE rotated 90 degrees anti-clockwise. So we've got C prime, D prime, E prime as our new triangle. So this is what happens to CDE when it's rotated 90 degrees anti-clockwise about point E. If you didn't know how to do that, what you could have done is just simply taken some tracing paper, and you are allowed to ask for tracing paper, and you could have just traced it out and physically turned the tracing paper 90 degrees, and you could have then visualized it and drawn the new triangle. So now we need a single transformation. We can't just we could have done a reflection and an enlargement or a whatever, but we need to do one single transformation that's going to map C prime, D prime, E prime onto PQR. Well, then let's join the points and see what happens. So if C maps to C prime and C maps to P, then if we join P to C prime, I'm going to change colour again so that we can see. If I join that, so basically we've got to find a way of a single transformation that's going to take this point and put it onto P, from C prime to P. Let's do the others. So D maps to Q, so D prime will map to Q. And R will map to E prime. Alright, so all of these lines converge on point 0, -1. So this is our point of interest. Right here at 0, -1. So we can think of these as all vectors. And then these would be the other vectors. So what's going on with these vectors here? So to go from 0, -1 to point E, we're going 1, 2, 3, 4 along the x-axis and -1 and -2. So that's 4, -2. So this is 4, -2. And so this same vector here is going to point R, which is 1, 2, 3, 4, 5, 6, 7, 8. So that's negative 8. To get from negative 1 to negative 9 is negative 8. So that's negative 8. And then 1, 2, 3, 4. 4. So what we're trying to do is map 4 comma negative 2 has got a map to negative 8 comma 4. Well, what we've done is we've multiplied both the x and the y coordinates by negative 2, haven't we? So 4 times negative 2 is negative 8, and negative 2 times negative 2 is 4. So this vector has been multiplied by negative 2. Let's just test our hypothesis with another one. Let's go from P to C, or to C prime. So to get to C prime, we've gone plus 1 along the x-axis, and minus 1, minus 2, minus 3, minus plus 1, comma minus 3. So that's 1, comma negative 3 has mapped to, so we've gone 1, 2, negative 2, comma 1, 2, 3, 4, 5, 6, negative 2, comma 6. So again, to get from 1 to negative 2, we're multiplying by negative 2, and negative 3 times negative 2 is positive 6. And let's just triple confirm it by going for this Q to D. So we've gone plus 1 comma minus 1, so it's 1 comma minus 1, which is mapped to so it's mapped to negative 2 comma positive 2. And again, that's an enlargement of negative 2. We're multiplying both by negative 2. So this is equal to multiply by negative 2. And this is equal to multiply by negative 2. And this is equal to... so I shouldn't really say equals. Forget the equals. They're just times by negative 2, isn't it? So what we're looking for as an answer is an enlargement of scale factor negative 2 centered on negative 1 comma 0. As you can see, there's negative 1 comma 0. Okay, I hope you found that helpful. If you're taking your GCSEs this year, I'd like to wish you every success with your revision and every success with your exams, and I look forward to seeing you in another video.